Welcome back. We are still in Chapter 3, Section 10. We're going to do an example of the racetrack principle now. So that's what we ended with in the last video, so we're picking up here with an example. This example, we want to use the racetrack principle to show that ln of x is less than or equal to x minus 1. So it is important to note that the domain we are interested in is the open interval from 0 to infinity. X minus 1 is a function defined everywhere, but ln of x is only defined for numbers greater than for x's greater than 0. Sorry about that. There we go. So we're only interested in 0 to infinity, and we'll see that x equals 1 is an important point. In this interval. So things kind of act differently in the less than 1 and greater than or equal to 1 chunks. So first, we're going to focus on x greater than or equal to 1. So we're going to say that g of x is the natural log of x, and h of x is x minus 1. Then taking the derivatives, we get g prime of x, which is equal to 1 over x, and h prime of x, which is equal to 1. My dog is snoring. I apologize for that. So we've got our derivatives, and to use the racetrack principle, we needed to see that g prime of x was less than or equal to h prime of x. And that's true. If we think about this, x is greater than or equal to 1. So 1 over x is going to be less than or equal to 1, right? It's going to be some fraction less than or equal to 1, which is less than or equal to 1. So great, there we go. Then let's say a equals 1, so we're going to have a as our starting point, right, because it's 1 or more. What happens at 1? Well, g of 1, ln of 1 is 0. H of 1 is 1 minus 1, which is also 0. Great. So they're the same. So then the racetrack principle with a equal to 1 says that g of x is less than or equal to h of x for x greater than or equal to 1. And put that back in context. That is ln of x is less than or equal to x minus 1 for x greater than or equal to 1. Good. Now we need to look at the other chunk. What happens when x is less than 0? Or not 0, sorry. What happens when x is less than 1? So when x is less than 1, I'm going to rename things. So I'm switching what g and h was. That way we can keep with the notation from our racetrack principle theorem. So now g of x is x minus 1, and h of x is ln of x. So g prime of x, that's 1, and h prime of x is 1 over x. So here, which one's greater? Well, if x is less than 1, if x is less than 1, then we see, what happens? Well, h prime of x is 1 over some number less than 1, so it's a number greater than 1. So h prime of x is actually greater than g prime of x, which, cool. That's again what we needed for the racetrack principle. So g prime of x less than or equal to h prime of x. Good. Now, instead of a equal to 1, we're going to say b is equal to 1, because b is now our end point, because we're going from, say, 0 to 1. So what happens there? We already know, but we'll say it again. G of 1 is now 1 minus 1, which is 0. H of 1, ln of 1, also 0. Good, they're the same. So what does the racetrack principle tell us here? Well, g of b is equal to h of b, and g prime of x was less than or equal to h prime of x. So the racetrack principle with b equal to 1 says that g of x is less than or equal to h of x. Oops, sorry. Doesn't say less than, it says greater than. So it says that g prime of x is greater than or equal to h prime of x for, this time it's technically x between 0 and 1, right, because x can't be smaller than 0. That is that x minus 1 is greater than or equal to ln of x for x between 0 and 1. So great, we accounted for both pieces and got the same result both times. So this tells us that the natural log of x is less than or equal to x minus 1. And there we go. That is an example of the racetrack principle. So we have finished up Chapter 3 now, and we'll be moving into Chapter 4. We'll be starting with Section 4.1 next.